Let's start today's lesson by talking about something that you've probably done a few times in your life, and that is typing an email. Now, most of us don't have a problem with doing this, even though it's actually quite a complex task. Your brain is coming up with a message on the spot, stringing it into proper sentences, while your fingers have to hit the right keys on the keyboard in sequence to make that message appear on a screen. All in all, it's a pretty tricky task that you're able to do quite smoothly, but all it takes is for someone to talk to you at the same time, and suddenly the task becomes extremely difficult. And not just because, you're using one hand to type while the other one holds the phone. It literally becomes harder to think of what to type when you're trying to process what someone is speaking to you. Why? Well, it has to do with something called working memory. Now, as we've seen in previous lessons, one way that memory is viewed is by using the Multistore model. This was proposed by Atkinson and Shiffrin in 1968, and not surprisingly, other models have since been proposed. We'll be looking at two of those. So in this old model, short-term memory was viewed as a single static storage location, but more recently it's been seen as a place where memory is consciously sorted and processed. Psychologists now refer to this as working memory. So what is working memory? Well, here's an example of you using it. Without using a calculator or writing anything, what is 8 times 63? Now, unless you're straight up a maths genius, this is probably a bit of a tricky thing to do. I personally don't know my 63 times table, although I do know my 8s. Whatever the case, I'm going to need to do a bunch of mental work to get this done. So looking at this, I figure out that 60 is 60 and 3. So if I figure out 8 times 60 and add that to 8 times 3, I should be able to get the final answer. 8 times 60 is 480, and 8 times 3 is 24. So if I add them up, what were those numbers again? 480 and 24. I should get 504. And that indeed is the answer. So in my head just then, I just did all this stuff, and that's a perfect example of working memory. So this model of memory, the working memory model, was proposed by Baddeley and Hitch in 1974, but updated by the same people in 2000 to include a couple of extra things. There is quite a lot happening in this diagram, so let's take a look at some important parts, starting over here with the visuospatial sketchpad. That is basically visual short-term memory. So it's storage of what we see. It allows us to see or keep an image in our mind as we process other things. It's basically, our short-term memory of all things visual. On this side, we have something called our phonological loop, and that is our auditory working memory. So that's storage of what we hear. It allows us to understand sentences of more than a few words. It's our short-term or working memory of all things hearing related. The episodic buffer in the middle is a bridge and filter between long-term memory, that's LTM over here, and the central executive, and storage components in working memory. And of course, you may have noticed all of this is being controlled by the central executive. What is the central executive? Well, it is responsible for switching attention from task to task and basically doing the big job of deciding what goes into or out of long-term memory. It does this through a few ways. One, by inhibiting, so by screening out irrelevant material, by switching, so moving attention from one thing to another, and finally by updating, so modifying items that have been brought into working memory from long-term memory, before then perhaps recommitting it back to memory through the episodic buffer. So the central executive is like the big shot. It makes big decisions about what happens within working memory. So how does this model play out in real life? Well, let's look at an example, actually one that you did before when I asked you what 8 times 63 was. The first thing that happened when I gave you that problem is that your visuospatial sketchpad probably helped you to see the problem in your mind, and in fact your phonological loop might have also helped you sound it out in your mind. Next, well, through my thought process at least, the central executive was the one that decided, hey, you can actually split 63 into 60 and 3, but next I'll need to retrieve my 8 times table from long-term memory to be able to do the next step. And so the episodic buffer, that bridge or filter, retrieves the 8 times table, heads back to the central executive, which figures out that 8 times 60 is 480, 8 times 3 is 24. And for a brief period of time, these two numbers need to be held in my working memory, either by the visuospatial sketchpad, seeing it, or the phonological loop, like hearing it, maybe repeating 480, 24, like quietly in my mind. And finally, back to the central executive, which takes those two numbers, adds them together to reach that final sum of 504. In fact, if you had to speak that number out loud, it probably would then go back to your phonological loop before it can be expressed through speech. 8 times 63 is 504. Now before we conclude, let's quickly revisit that initial scenario of you trying to type an email while talking at the same time. You see, this working memory model explains why it's easy to do a visual spatial task, like typing, and a language task, coming up with words or sentences, at the same time, compared to two language tasks, like thinking of what to write in an email while someone's talking to you. Both of those tasks are using this same store, making it much harder to do simultaneously. Understanding this working memory model actually helps you maximize the way that you multitask. Alright, that concludes my introduction to the working memory model. In the next lesson, we're going to be looking at the levels of processing model of memory.